Okay, welcome back to McNab Chemistry. Today we're going to have a look at organic chemistry, naming compounds, in particularly the language. But first of all, we're going to look at all the different functional groups that you need to know for pretty much the whole of your A-level chemistry. Okay, so first of all, it's really important to understand what a functional group is. So a functional group is an atom or group of atoms which, when present in different molecules, causes them to have similar chemical properties. Okay, so basically whenever you do organic chemistry, you look at the molecule, you identify your functional group, and depending on what functional group it has will tell you a lot about the type of chemical reactions that molecule will go through. Okay, so here is a list then of functional groups that will take you through your A-level. Okay, so first of all, alkanes, when you've got a carbon-carbon single bond. Alkenes, when you've got carbon-carbon double bonds. Haloalkanes, when an alkyl group, so R is an alkyl group, when that's attached to a halogen, so X is your halogen, so chlorine, bromine or iodine. When you've got an alkyl group attached to a chlorine, we call them chloroalkanes, as long as the R group is an alkane with carbon-carbon single bonds, obviously. Okay. When we've got RBr, the bromoalkanes, Ri, iodoalkanes. Okay, so our example here, we've got meth, eth, we've got two carbon atoms, so the molecule is based on ethane because we've got a single bond between the two carbons, but it's got a chlorine attached, so it's chloroethane. Okay, our next functional group then is our alcohols. Okay, so we've got, when we have an OH group attached to an alkyl group, so I'm looking for the OH, meth, eth, that's eth, and it's ethanol, ethan alcohol, ethanol. Okay, our next functional group then are ethers. Now, we don't strictly need to know these, however they are useful to know because they appear in isomerism questions and they're quite useful solvents in year 13. Okay, so when you've got an alkyl group here attached to an oxygen in between two alkyl groups, so that's one carbon, so that's a meth and that's a meth with an oxy in between, so it's methoxymethane, methoxymethane, methoxymethane. Aldehydes, when we've got the CHO group, RCHO. Okay, so 1, 2 carbons, meth, eth, ethan, aldehyde. Okay, so it's an aldehyde, ethanal. Okay, ketones, when we've got a carbonyl group here, C double bond O group, in the middle of a carbon chain like that, so 1, 2, 3, that's my longest carbon chain, so it's prop, anone, so it's a ketone, propanone. Okay, next functional group, carboxylic acids, COOH. So whenever you see a COOH or a COOH, they're all the same thing there, COOH, COOH, COOH. Okay, you've got a carboxylic acid. Okay, that's just the displayed formula because all the covalent bonds are shown between the atoms. So I identify my functional group in this molecule here, COOH, so 1, 2 carbons, meth, eth, always count away from your functional group, meth, eth, ethanoic acid. Okay, number 9, then esters, R1COOR2. So really the difference between esters and carboxylic acids is that the H of the carboxylic acid has been substituted by another alkyl group, in this case a CH3 group. Okay, so that's a methyl group, that's meth, eth, it's based on ethanoic acid, so it's methyl ethanoate, methyl ethanoate. Then we go to amines. This is where you've got an NH2 group in a molecule. Okay, so again, there's my NH2 group, so I know it's an amine, and I've got a meth, eth, I've got an ethyl group attached to my amine, so it's ethyl amine, or you could call it aminoethane. Then we go to nitriles, RCN, C triple bond N attached to an alkyl group. So whenever you see CN in a molecule, you know it's a nitrile. Okay, you've just got to be a little bit careful when you name these, because that carbon does form part of the longest carbon chain. So 1, 2, I've got 2 carbons there. 1 carbon, 2 carbons, so it's ethane, nitrile. So methane, nitrile, 1, 2, ethane, nitrile. Okay, this next one is useful to know. Alkyl hydrogen sulfates. Ooh, sounds quite difficult, but actually it's not really very difficult at all. So hydrogen sulfates, okay, well sulfuric acid is a hydrogen sulfate. So let's have a look at the difference between the structure we've got here and sulfuric acid. Okay, so all we've done here is we've substituted one of those H's for an alkyl group. So instead of having H2SO4, we've got RHSO4. So it's a hydrogen sulfate, and I've attached an alkyl group onto my hydrogen sulfate, hence the name alkyl hydrogen sulfates. Okay, so there's my hydrogen sulfate part of the molecule here, and I've got a I've got an ethyl group attached onto the hydrogen sulfate, so we call it ethyl hydrogen sulfate. Okay, number 13, cycloalkanes. Okay, so I've got a nice ring of carbon atoms there, each with hydrogens attached onto it. So there I've got 1, 2, 3, 4, 5, 6 carbons in a ring, so it's called cyclohexane. Number 14, cycloalkenes. Okay, so same idea as the cycloalkanes, except this time it's an alkene, so we've got a double bond in the ring. So 1, 2, 3, 4, 5, 6. So it's cyclohex, and then because I've got my double bond, it's cyclohexene. Okay, number 15, hydroxynitriles. Okay, this is getting into year 13 work now. Hydroxynitriles, this is where you've got a hydroxy group and a nitrile group all in one molecule. Okay, so I've got an OH group and a CN group in one molecule. So I've got hydroxynitrile. So what's my nitrile there? It's 1, 2, 3. So it's it's propane nitrile. Okay, and my nitrile functional group started there, so that's carbon number 1. So therefore that must be carbon number 2. That must be carbon number 3. Okay, so it's propane nitrile, and the OH group comes off the second carbon, so it's 2 hydroxy propane nitrile, 2 hydroxy propane nitrile with a hydroxy group coming off the second carbon, so 2 hydroxy propane nitrile. Also note this is now very, very important. Whenever we've got a number and a letter, you need to put a dash like that between the number and the letter. Okay, acyl chlorides at number 16. Okay, RCOCl. Okay, so now what we're doing is, if you remember back to year 12 chemistry, we looked at compounds like RCCl. Okay, if I put my thumb over there, that would be a haloalkane. But now all we do in year 13 is we start to introduce the carbonyl group, the C double bond O group, into molecules, and it does actually change the chemistry of these molecules, and it actually makes them even more reactive. Okay, so this molecule here is called an acyl chloride. Okay, so we are now introducing the C equals O group into compounds, okay, known as the carbonyl group. This makes these compounds more reactive than, for example, the RCl, the haloalkane from which it came. Okay, so RCOCl, let's just have an example of that. So if I go CCOCl, H is on there, H, that's meth, that would be called eth, and oil chloride. So methanoyl chloride. Okay, so why are these more reactive then than the equivalent haloalkane? Well, if you look at the molecule, we've got this oxygen and the chlorine attached to that carbon. Well, that oxygen is more electronegative than the carbon, so therefore we get a dipole across that bond, making that carbon delta positive. But the chlorine is also more electronegative than the carbon, so that also drags electron density towards it. So electron density getting dragged that way, electron density getting dragged that way. So both of these two are making that carbon delta positive. So it's a combined effect of both of these making that a bigger delta positive. So therefore it's more open to attack from nucleophiles. Okay, so C becomes very delta positive and is therefore open to attack from nucleophiles. Okay, at number 17 then, we've got acid anhydrides. Okay, so let's have a little look at this. So R1COO, C double bond O, and then that carbon there attached to an R2. Okay, so it's almost like having two carboxylic acids attached to each other. Not quite that, is it? But it's similar. Okay, so this one here, I've got ethanoic acid that here. Okay, ethanoic acid-ish here. Okay, so we call it ethanoic anhydride, meth-eth ethanoic anhydride, because it's two of them put together. Okay, I've got a COC bond there in between the two parts of the molecule. So similar to acyl chlorides, but instead of having a Cl on the carbon, okay, acid anhydrides have the R2COO. Right, it's really important that when you consider acid anhydrides, you think how similar they are to acyl chlorides. Okay, so if that's ethanoyl chloride, meth-eth ethanoyl chloride, so that's an acyl chloride. What's the difference between the acyl chloride and the acid anhydride? Well, it's this Cl here on the acyl chloride is being substituted in this case by a CH3COO. Okay, so when you're looking at them, see this bottom half of your acid anhydride as a Cl atom, and that really helps when doing exam questions. Okay, right, at number 18, look what we've got here. Well, it's an amide this time. It's not an amine, it's an amide, and look what we've done. If the amine was RCNH2 or RCH2NH2, the amide, because we're in year 13 now, we introduce a carbonyl group, okay, into the amine. When you introduce a carbonyl group into an amine, you get an amide. Okay, so there we go, RCONH2. Meth-eth is called ethan amide, and it's an amide, isn't it? So we're going to call it ethanamide. Okay, meth-eth prop, that's meth-eth prop, so it's prop, and it's an amide, propanamide, propanamide, or propanamide, propanamide. There we go. Right, and then finally, just three more to finish off. Number 19, we've got benzene. Okay, C6H6, and it's drawn like this, so carbon 1, 2, 3, 4, 5, 6, with electrons delocalized around the ring. Okay, the benzene structure is this, and it's not this, okay, and because we don't have in benzene the definite carbon-carbon double bond, single bond, double bond, single bond, double bond, single bond idea like we have here. Okay, right, so and then at number 20 we've got dicarboxylic acids. So dicarboxylic, we know what that means, two carboxyl groups on something like a benzene ring, it could be. So that would be benzene 1,4-dicarboxylic acid. Benzene, position 1, 2, 3, 4. Dicarboxylic acid, because I've got two of them. Benzene 1,4-dicarboxylic acid. Okay. Also note that between letters and numbers we've got a hyphen, but between numbers we have a comma. Very, very important. Okay. And then finally, coming in at number 21, we've got diamines. Okay, so diamines means we've got two amine groups somewhere around a carbon chain. So here's my carbon chain. Okay, and this is 1, 2, 3, 4, 5, 6 carbons. Okay, so it's hexane 1,6-diamine, because my amine group or amine groups are on position 1 and position 6 of the carbon chain. Okay, so those are all of the functional groups required for your A-level chemistry. I hope that's been helpful. Please write them down, please learn them. Thank you for watching, and don't forget to like and subscribe, and click on the bell notification to stay fully updated.